half of the book. So I'm glad that you're all here. Good morning, and we're gonna be, I guess, dealing with the systems of equations and solve them either using so-called substitution or elimination. I'm sure that you already encountered such type of exercise, but our goal is going to be to expand it a little bit further. So, for example, if I look at example 2, we have a system with two equations that has two letters. People say unknowns, x and y. So in order to solve this system, I'm going to try to get rid of one of the unknowns. So when I'm looking at the equation they gave us here, I noticed that first starts with 2x and the second starts with 4x. So I could eliminate unknown x if I doubled my first equation. So if I distribute number 2 over both sides, so if I multiply on the left side by 2, let me write this 2 a little bit better, as well as on the right side of this equation by number 2. So that way we're going to not change our equations. In other words, my first equation will look like 2 times 2x plus 2 also multiplied by y. And on the other side, it'd be 2 times multiply whatever's on the right side by number 5. Then second equation, I'm gonna leave the way it is because it starts with minus 4x. And if you multiply negative 2 by positive 2, what you're gonna end up with will be 4, right? 4x here. So together with negative 4x, so here's the system side, they will cancel each other because plus 4x and minus 4x make x terms to disappear. And then with y terms, I'm gonna also add, so we're adding these two equations. So 2x, 2y, and 6y will add to 8 of those y's. And on the other side, it will be 2 times 5, which is 10, added with negative 2, so I just keep adding these, and get positive 8. So notice that we were able to get rid of the unknown letter x, and this tells us that y is equal to 1, right? 8 times 1 is 8. So we solved it for y, and we found one of these unknown.
Professor,
Yes.
if you multiply that 2 by that negative 2, wouldn't that be negative 4?
It's positive 2.
Oh, okay.
There's no minus, no minus. Negative 4 is underneath, is waiting for us to cancel with positive 4. So I need.
No, it's just that I thought that was a negative right in front of the 2x.
No, there's no negative. It's positive 2x. That's how they gave it to us. Because if it was negative, then I would have probably had to change the sign and multiply it by also minus 2 to get positive 4. Because my goal is to cancel that minus 4x. And to do that, I need plus 4. So signs need to be opposite. So they cancel. Because indeed, if that'd be minus 4 and minus 4, it'd be minus 8. And there'd be no point of doing it, right? Because it wouldn't get canceled. So anyways, I found y. The question is, what about another unknown? What about letter x? So I'm going to go ahead and take this equation that we just worked with, 2x plus y. Now we put plus 1 instead of y is equal to 5. So we can see what x is equal to. So we do some solving of equation. We subtract on both sides, number 1, right? So we have 2x in here, and it goes to 4 on the other side. And that means that x is what? 2, right? 2 times 2 is 4. So we found that x is 1 and y is 2. And that's what means to solve equation. You need to find a pair x and y that work for both equations, which means if I decide to check, I'm going to put in the first equation 2x plus y is 5. So it'll be 2x and x is what? We just found it. It's 2, right? Plus y, which is 1, right? And this is equal to 5. And indeed it is. So that one checks, and that's great. And the second equation, analogously, I'm going to replace x with a 2, so it'll be negative 4 times 2, and then 6y, so it'd be plus 6 times 1. Would this equal to negative 2? Well, we have a minus 8 and plus 6, and indeed it is negative 2. So this pair checks in both equations. And that's what means we solved this system. So do they actually solve it here? They probably do somewhere where, let's see. No, they don't, but that's okay. So what they do now, oh, actually, it is analogous system of equations they solve here in example 3. It's a little bit different because on the other side here, instead of minus 2, we have plus 12. But it's kind of similar to what we just worked out. And figure 2 gives us one very interesting observation. So they graph the first equation, which is a line in here, and it's like a blue line, looks like. And the second equation is graphed as a red line. And they found the point of intersection, the pair that we just found, point with coordinates positive 2 and 1. And this point is actually intersection point of these two lines, because its coordinates 2 and 1 for x2, for y is 1, worked, and in the first equation and in the second equation. So it's a point that is common for both graphs, for both lines. So it is intersection of those lines. In other words, to solve system of equations graphically, we find the point of intersection of those two lines. And there are various ways to solve this. Like, for example, here they use a little bit different approach. They substitute. So they pull out one letter like y here, and then they put this in the other equation. So it's up to you how to solve the system, because solution is going to always be the same. So today's goal is to practice to solve those systems of equations. And what I'm going to do is go to the end of section as usual and get a couple of other exercises to work out, to start, to, people say, eliminate, because the way I proposed to solve this system was method of eliminating one of the unknowns. I was able to eliminate my letter x, and that's a very popular approach in solving the systems. So let me try to use it to do another exercise. Let's say move to group that starts at 17. So clear a little bit that, and try to do exercise. Well, 17, I think, is a nice problem to start with, because in exercise 17, when you look at these two equations, you will right away feel like eliminating letter y, probably, because if you were to add y and minus y, your y's will cancel, and you will be able to find x. So point is, we always look at the system, at both equations, and then we decide which unknown will be easier to get rid of, to cancel. So if my equations have the opposite signs with y's, then I can add those two equations with each other. And when I add, the y's will disappear. So plus y and minus y will cancel. And that's our goal, not to have one of these letters. So we end up with x plus x, or 2x on the left side, and 8 plus 4 will be equal to 12. So x is equal to 6, because 2 times 6 is 12. So we can quickly find one of these variables, such as x in this case. And then we can use any of these two equations, let's say the first one, in order to get another variable, to get letter y. And to get y, I just need to put this 6 instead of x. So there will be 6 plus y is equal to 8, and we can see that's 2, right? Because when you drop 6 on both sides of this equation, notice we always do the same operation on both sides of equation, so equation doesn't get changed. We get y, it is 2. Someone can say, Alex, I could eliminate my x differently. I could subtract x and x so they canceled. Would that be okay to do that? Yes, it doesn't matter how you solve it. You feel like subtracting? Okay, just be careful when you subtract negatives. So if you subtract, y's will be x is canceled. So there'll be y minus and minus. It's plus y. So that'd be actually 2y's, right? When you subtract is equal to 4. And notice this is telling you that y is equal to 2, because 2 times 2 is 4. So you could get y first if you eliminate x, or you could get, like I did here, x first when I eliminate y. It doesn't matter. You find one unknown, then you go for the other. You say, so which way should I solve it?
So let's say you eliminated the x's, you would have 2y and then just solve it like that regularly.
Yeah, it's 2y, and it is 4 because you added the right sides, 8 and 4, but you subtract them, right? Get 4. So you get y is equal to 2. So the point is, it's up to you how you want to solve this system, because the answer is always the same. And if you solve it correctly, you give me correct answer, that's it. I'll be very happy. I guess that's all we have to do, right? Find solution, find pair x and y. So if you practice to do a few of these problems, you'll start to see this better and better. And like in the exercise 22, I would say the system is pretty much solved here, because we have only one unknown in the second equation, so you don't really have to do much in here just to get y out. So this is 4x plus 5y's is -3, but the second equation tells you already that minus 2y is -8. Oh, and this is great, because the second equation, right away, you can divide by the same number -2, right? On the left and on the right. So you will see that your unknown y is what? 4, right? So now we can use the first equation to find x. I say, why don't I use the second equation to find x? Well, there is no x in the second equation, so I have no choice but use the first equation. So put it in the first equation, that number 4 that we found instead of y. And this way you can get x. So you need to bring something to the other side, right? You need to subtract this 5 times 4 or 20 on both sides. And notice there'll be something fractional coming out. And that's okay, because some problems, they have fractional answers. It's like here, we have to divide by 4 on both sides, right? To get x equals to, well, whatever it came out to be. It is -23/4. Okay, so it'll be some negative number, 23/4. If you wish, you can pull out the actual answer, such as like what, 5 3/4 or 5.75, whichever you prefer. But yes, the answers could be fractional, and there's nothing to panic about when you see the fractions, because we already worked a lot with fractions, right? And we'll just do some more. Notice that in this exercise, I didn't have to eliminate any unknowns because x was already eliminated in the second equation. But sometimes you need to, well, struggle a little bit in order to solve this for whatever unknown you want. Like try 28. It looks like first equation is 3x plus 3y is equal to -1. But the second equation here has only y terms. So it is 4x and plus y is equal to negative or positive 8/3, right? 8/3. So we got this second equation with a fraction. And that's fine. There could be fractions, doesn't really matter. But question is, which unknown should I eliminate? Well, definitely not x, because there's 3 and 4, so they're not very friendly with each other. But with y's, I have 3y. So if I had a -3y, notice I want to always have opposite signs. So I put a -3. I need to multiply by this -3 my entire second equation. So this way, I'll be able to get rid of this y's, right? So I'm going to copy the same exact system again. First is the same equation. The second is -12, 3 times 4, minus 12x, and then minus 3y, because it's 3 times y, so it's -3y. And this is going to be also negative, because we have 8/3 times 3, and notice that 3 will cancel, and that's great. It'd be -8 we have on the right. And again, when I add these two equations with each other, the y's will cancel, and that's just what we needed, right? So we have -12 and 3, which is -9 times x is equal to -9. Oh, that's great, because x is 1, right? X is equal to 1. I like that. It's a nice solution. So the question is now, which equation should I use to find y? And definitely not the second equation, because second equation has fraction 8/3 in it. So doesn't matter which equation you use, so I will try to do it simpler way to not encounter fractions. And 1 instead of x, I'll put in the first equation. So I need to carefully replace my x with whatever we found. It was number 1. So it'll be 3 times 1, which is 3, which is what I'm going to subtract on both sides, right? So ending of this is standard. I'm sure you know it already how to solve. So it'll be -4, right? Okay, so divide by 3. You will get another solution with a fraction. And we already know it's not a big deal. -4/3 is what we have for y. -4/3. So we're solving systems of equations. We always need to find both and x and y. Well, it turns out that sometimes you can't solve it. Let me show you another case. The case when those two equations, when I graph them, do not intersect each other. And that's what they're talking about as a special case that doesn't appear too often. Example number 7. In example number 7, on the figure 3, you can see that these two lines, they don't have any points of intersection because they're actually parallel lines. And that means that we have no solution in our system. In other words, no intersection. I say, well, if I solve it, how will I be able to get this idea? Well, let us see how we can solve this system anyways. Just eliminate one of the unknowns, either x or y. I guess in this case, it's up to you which unknown. I say, okay, so let's multiply it by -2. So it'll be like a -2 times y. And that's what actually they do, I think, in here. So if I multiply by -2, my first equation, actually they solve it a little bit differently. But anyways, let me distribute -2 over first equation. So that'd be -4x, right? And -2y. And this is equal to 5 times -2 is -10, right? Okay, -10. The second equation stays the same, and we actually had a goal to eliminate letter x, and looks like -4x and +4x will cancel each other out, and just what I need, right? So that they just cancel. I say, Alex, when you add these two, y's will also eliminate, they will also cancel. Okay, so everything cancels, we get a 0 on the left side, and on the right side, then we have -10 plus 8. -2. So what is this? They're not equal. So you say, no, it's not possible because 0 is not -2. Well, no means no solution. Means that these two perfectly nice equations don't go with each other, don't have the common point of intersection. And that's what we just saw. So sometimes you end up with something that makes no sense, like a 0, which is not -2. That means that these two equations don't go together. They don't intersect, so there is no solution. That's the idea. So whenever you get something, when you solve the problem that makes no sense, it means there's no solution. So it doesn't make sense. Okay, so sometimes this thing happens. And sometimes there is another case appears, and they discuss it here. I think they made a nice set of pictures on the figure 1. And turns out there is a third possibility. The third case when one line is exactly the same as the other line. So they coincide, those two equations. So there'll be infinitely many points of intersection of these lines because this is exactly the same line. And that's the case when you have infinitely many solutions, because any point is solution and there are infinitely many points on the line. And that's why people say there are infinitely many solutions. And I can just try to find that last case for you here. So let me see if they have a nice picture, because I love their pictures. I'm just so impressed because it's kind of hard to make such nice pictures. So do they have infinitely many solution case? Somewhere they should have it. I think here it is. They have two lines, the blue and the pink, that coincide with each other. And that's the other thing I wanted to look at, and that's what's an example 8. So what happens in example 8? Well, as usual, if we try to eliminate, if I multiply by -3 my first equation, because I can get a 6 and -6. And you say, Alex, why negative? It should be +3. Yeah, they should multiply by +3, so they cancel, right? So there'll be 6x and -6x, so they will go away. So I have to also multiply by this +3 each piece of my equation. So this way x's cancel, and then y is also gonna cancel. I say just like it happened in the previous example. Okay, yes. So we get a 0 on one side, and this is gonna be equal to 12 minus 12, also 0 on the other side. So it is the case when everything is fine, 0 is equal to 0. But what's our solution? Well, infinitely many solutions. What does it mean? Well, it means that whenever you have point on the first line, it's going to be the same exact point on the second line, so they cancel. So that's why we have infinite solution, and that's what they're trying to explain here. So they say, for example, when x is 2, then y is 0. So if you have a point with coordinates, let me scroll this down, 0 for y and 2 for x, like 0.20, then it will belong and to the first equation as well as to the second equation. In fact, you could simplify this a little bit differently to better see that this is indeed exactly the same equation. So if I say take my second equation and multiply it, actually divided by -3 here, and then everywhere else here and there, look at the second equation. It'd be 2x and also 3 divided by 3, so that'll be just 1. Negative and negative cancel, so that'd be +1y, or just y, equals to 2 negatives cancel, we got 4. Isn't that exactly the same as my first equation? So yes, indeed, we have the case where both equations are the same. So you say there's just one equation. Yeah, and that's why when you subtract them, they cancel, everything cancels. You got 0 is equal to 0. So they're identical equations, the same. No wonder everything cancels when you subtract. And that means that there are infinitely many points that solve this system. So every point that goes with the first equation will also go with the second equation. And that's the third case. And that's the last case. And I guess that's the last thing I wanted to discuss today, because this section has more in it. And I just wanted to start to introduce you with solving these little systems with 2 equations and 2 variables, because we're gonna also see the case with 3 equations and 3 variables. And that's a little bit extra to do, and that's what they actually show you on the figure 5, the possibilities to solve with X, Y, and Z. And the systems, well, they get a little bit larger, definitely. And if your graph turns out, then they will be looking for the points of intersection of planes, 3 planes in a space. So sometimes they intersect, in fact, in most cases, only at one point, and that's called solution. But to graph it, it's pretty difficult, and that's why we don't graph. But this picture is something that gives us intuition in what this is gonna look like. So there could be one point of intersection, or it could be like an open book. They could have a common core, like a line where they intersect with each other along this line, and that's infinitely many solution case, right? But there could be another possibilities how they will be graphed with respect to each other. So we're gonna discuss this next time, because I think it'd be a little bit overwhelming for Monday, right? So I'm gonna let you go today without a quiz. Next time, maybe we'll have a little quiz on this. So just try to start to get used to eliminating one of the letters, either X or Y. And then on Wednesday, maybe I'll find some nice exercise for you to work out. So this way we'll have maybe quiz next time. Okay. So enjoy the rest of Monday, and thank you for coming.
Professor,
Yes.
any grades yet or not yet?
Oh, grades will be this week. I plan to give you another quiz on Wednesday, because there's still some people that did not do anything, and I try to actually send them a reminder of that. So I hope to wake them up. I know that usually people start working, some people, on a week 3 of class. This is week 3. But if you took both quizzes, then everything is fine. You will get a perfect grade. And just go to wait a little bit for others to submit their work.
Okay,
Yeah, so like maybe by Friday, I think I will have your grades posted on Canvas. So far I didn't put anything there yet.
okay.
Mhm. Okay, so I guess I'm gonna stop to record and let you enjoy the
Have a good
rest
day.
of Monday. Thank you.